right, let's kickstart this. I heard we have to speed up because there's also food on the way. It's a bad joke. In a couple of minutes, we're going to have two presentations from Filip from Noname Security and also from Jiri from Software AG. I will not present them. I think those people are much better in presenting themselves than I would ever be. So I will let them up to them. Maybe just a quick word on our community, and then we kickstart with the presentations. API community. We have as mission to bring the Belgium APIs experts together for monthly meetups to have a nice experience of knowledge, to have a good conversation with a nice drink and some good food. So happy to be able to do that again this evening. Today, I think we're on the 6th real meetup, so we are very happy that we can leave the pandemic behind and that we can meet each other again in real life, because Teams was good during the pandemic, but it's not the same as meeting each other. I wish to thank Noname for organizing this. And yeah, quick word, how can you find us? I assume the majority of you already know that, so you can find us on apicommunity.be. Subscribing to our events you can do through meet.apicommunity.be, and of course we're also on LinkedIn. And the recordings you can watch on watch.apicommunity.be. So if you would have colleagues that are interested in the subject but that could not make it this evening, recordings will be uploaded later this week. Yeah, a small thank you to all of our partners that make this happen, and of course this evening to Noname as well. And just to save the dates, January the 24th, our next meetup is going to be with Deloitte, and then May the 4th, Star Wars Day, we're going to organize our API and integration conference. More on that is going to start following in the coming weeks and months. And now I will give the word to Filip. Filip?
All right, thanks very much. I'll try to stick close to the laptop for the recording of the sound, but I'll also mainly do a demo, so that's the other reason. Yeah, so my name is Filip Verloy. I'm a field CTO with Noname Security. What I'll talk about in the next 25 minutes or so is mainly securing APIs. So the idea is there's of course a lot of, let's say, growth in the usage of APIs. I guess you know that better than I do. But what we're sort of seeing is that people are attempting to secure APIs using sort of the old paradigms of, you know, inline security devices or web application firewalls and things like that. So I wanted to use an OWASP project called crAPI or crAPI to sort of show you what some of the API security vulnerabilities are. These are real-world vulnerabilities to sort of demonstrate why you have to spend a little bit more attention in terms of securing your applications and securing your APIs. But before we do that, I wanted to show you a little demo about breaking Wordle. So I don't know if anybody knows Wordle, that word game, daily word game. It's also Bill Gates's favorite game, apparently. So if you go to Gates Notes, his blog, he talks about the best strategy to beat Wordle every day. So we pick certain letters which appear more often in 5-letter words and so on. So he has this big strategy on how he's probably one of the world's best Wordle players. So on the one hand, we have Bill Gates' strategy, and on the other hand, we have a generic hacker. This is Inti de Keukelaar, by the way. It's not a generic hacker. So what I'll do is I'll show you how to hack Wordle. It's maybe an interesting party trick for the New Year, the holiday parties with your family. So if we go to Wordle, and if I accept cookies, so what I'll do is I'll just open up developer tools. Sort of what will happen now is that if you look at the OWASP API Security Top 10, It's a top 10 list of the most common API security vulnerabilities. And excessive data transfer is sort of, I think, in the top 3 is the third biggest one. And this is sort of the vulnerability that we discovered with Wordle, which is now owned by the New York Times. So it is a pretty visible thing. So what I'll do is I'll just reload, and we see this JSON here. So if I look at the JSON code, you can see that they're actually sending the solution as part of their server response. So the idea is that if I close this down and I do, I don't know if you can see it, maybe I can make it a bit bigger. So the solution is third, right? So if we do THIRD, enter. According to Wordle, I'm a genius. That's what Wordle said. So the idea is that stuff like this keeps on happening. So if you look at the crAPI API, which is this open source tool, it sort of looks ridiculous, the extent of vulnerabilities in that application. But as you can see, these vulnerabilities just happen in real life just as much. So we really need to spend a little bit more care and attention in securing our applications. So yeah, if you want to impress your friends during the holidays, feel free to break Wordle. You'll be in the top 10 list easily. All right. So now that we saw how to break Wordle, you're officially a certified hacker, of course. This was, it's number 3 of the OWASP API Top 10 vulnerabilities. So this is the list of 2019, which is the latest one. There's going to be a new one early next year. I hear the draft is going to be out in January, and then probably in March there will be a final version. I expect it to be close to this list, but maybe some things will move. But that's sort of what we can sort of demonstrate using this crAPI API. So that was one example. I have another quick example which I won't demo because of time constraints. But I ordered a Tesla in May, and just like everybody else who ordered a Tesla, we are all sort of waiting for our delivery. Apparently, it's going to happen before the end of this year still, which is in the next week. But what you can do is they have a leaky API, Tesla. So in Tesla, you can look for your secret VIN number. Once you have your secret VIN number, you can correlate it with the cars that are currently on a boat from China to Zeebrugge in Belgium. So you can track where your new car is. So even Tesla, with all of their brilliant engineers, have a leaky API. So again, they're also vulnerable to this excessive data exposure. There's many more examples out there as well. So I think this year Optus was the big example, Optus Wireless in Australia. So they leaked about, I think, 11 million PII records. But Coinbase was an interesting one in February of this year. So what happened with Coinbase, they have a trading API. And what you could do is you could own an account with 2 currency accounts linked to the same user account. And mid-trade, you could stop your transaction and switch currency account. So what you could do is you could have one account where you had let's say Bitcoin, and another account where you had a cheap cryptocurrency, maybe Shiba Inu. In the Bitcoin account, you have maybe 0 Bitcoin, but you have the currency Bitcoin listed. In the second account, you have, let's say, 100 Shiba Inu. So what you could do is you could start a transaction to sell Bitcoin, 100 Bitcoin, exchange it for US dollars. You start the transaction. The initial logic validation is, does this person have Bitcoin in the account? That validation passes because, yes, indeed, he has Bitcoin. Then he switched to the secondary account where he has 100 Shiba Inu. The second validation was, does this person have 100 of the coin he's trying to trade? That passed as well because they didn't check on Bitcoin anymore. So this person could sell 100 Shiba Inu for the price of 100 Bitcoin, which was about a $330,000 US profit. So stuff like that keeps on happening. So onto the OWASP crAPI. So crAPI, or completely ridiculous API, to use its full name. So it's a vulnerable application You can run it on a container, so you can test with it yourself. It basically exposes that OWASP API top 10 vulnerabilities list, and it allows you to sort of attack those APIs to get a better understanding of, what does that look like? What does that security look like? So what I did is I set it up in a lab. This is the logical architecture of my lab. So I'm running it inside of AWS. I'm running it on an EC2 instance. So I'm running that crAPI container on an EC2 instance. In front of the EC2 instance, I'm running the AWS Web Application Firewall service. And in front of that, I'm load balancing it using ELB. The way that I'm getting the traffic out of the system for us to inspect it. So what I'm doing is I have, from a Noname perspective, an out-of-band solution that really doesn't sit in the transaction path. So we're not really involved in, let's say, looking at the transaction and then blocking the transaction in real time or validating it like a firewall would do. What we do is we sit out of band and we monitor all API communication. So in this case, the way it works is in AWS, you can set up VPC traffic forwarding depending on the instance type that you have. This sends a copy of all API traffic into our collector, and that's what we will use to sort of validate what's going on. And the reason that I'm using Noname is just to sort of show you what an attack looks like. I'm not trying to sell you Noname. So it's more that you have some sort of visibility into what's happening from an attack perspective. All right, so let's go to our application. So this is the crAPI application, which is basically a web app that allows you to look at a car that you own. It also has a web shop where you can buy parts, so things like a car seat or wheels. So I can go in and say, buy me a set of wheels for $10. The dashboard shows you, the type of car, the fuel type, how old the car is, but it also shows you the location of the car. So based on latitude and longitude, where is my car currently parked in the world? They also have a forum in this application where you can post messages and exchange ideas and so on. So the one attack I'm going to try to demonstrate is a broken object level authorization attack. So the idea is, even though the crAPI application itself has the top 10 vulnerabilities, just in the interest of time, I'll sort of focus on BOLA. And the other reason I focus on BOLA is that's really the hardest attack to overcome, really, to be honest. So if we go to the dashboard, we can see the transactions, right? So let me move this out of the way, maybe. So we can see the transaction. So if I look at dashboard, for example, and if I see what comes back, so if I'm looking at the dashboard, I'm getting my ID, I'm getting my username, I'm getting I'm getting my email address, I'm getting my number. And as you can see, all of these things aren't really displayed in the dashboard. So the dashboard API is sort of already exposing way too much information for what the application needs. This is sort of typical, whereby the backend sends all of the information that it has, and then it sort of relies on the front-end developer to filter out what to show. But of course, from a security perspective, that's a vulnerability, because if we can intercept that, which we easily can, then of course we could try to learn or manipulate that application on the basis of that additional information. So if I look at this information coming from the dashboard, there's not a lot of super valuable information here, I would say. What I could do is I could try to simulate. So if I go back to my headers here, I can see which API we're sort of requesting. And what I can try to do is I can try to simulate a direct connection to that API, which of course wouldn't work in this case, because we don't have, in this case, a valid bearer token to authenticate ourselves against that endpoint. So that's sort of what we are expecting. But of course, if you look at the developer tools again, we can see that bearer token is part of what the server sends back. So we could potentially if we have the right plugin in Chrome, HTTP mod, for example, we could copy in that bearer token HTTP mod and then launch a direct query to the backend API. So if I would take this authentication token here, and in my case, I'm just going to use Postman. So I would be able to talk directly to the backend API. So for example, here, if I'm doing a GET request to the dashboard, what I'm putting in here is that bearer token in authorization. So if I launch that request, I get back the same information. So my goal now is, can I somehow find additional information that doesn't belong to me? And can I, with the same bearer token, so with the same authorization token, can I get to other people's data or other people's objects? That's really what a BOLA attack is about. It's about using or extending your own authorization to such an extent that you can query other objects that you're really not authorized to use. The problem is that from a inline security device, you somehow have to be able to match who that authorization token belongs to with the objects that are being queried on the backend. So if there's no straight connection between a user ID and that bearer token, that's going to be very problematic, which means then you're going to have to do it over time. So we're going to have to look at all of the subsequent transactions and then figure out, is this the same user? Is it coming from the same IP address? Maybe is he using the same job token each and every time? And can I match it with the same user? So that's really the problem. So really what we're trying to do then is figure out, is there a way for us to query something that we shouldn't have access to? So in a dashboard, there doesn't seem to be much information, right? So if you look at the response, doesn't seem to be much information. If you look at the shop, we get back products, nothing there, really nothing there. If I go back to dashboard, there's also a location API. So if I query the location API, in this case, I can see there's a car ID, right? So the location API gives me back as a response a car ID that's assuming unique to my car, and it gives me a username, but it doesn't give me an ID. So again, from a firewall perspective, there's no way for me to link this car ID with this user because a full name is not a unique identifier at all, right? So that is a bit problematic. So I now know if I can find a car ID, I can get back a latitude and longitude. So that's really the goal, is can I see where somebody else's car is parked in the physical world? Again, referring back to Inti, that's sort of what Inti figured out with 4411 a couple of weeks ago as well. Like you can query the full 4441B mobile database, and then you can sort of figure out if people drove into a parking garage because of the NPR camera registers the number plate, and then you can sort of query it. So we're trying to do a similar attack here. So if I go to contact mechanic, for example, I have an endpoint. There's no vehicle ID in that endpoint, but there is additional information. Like there are email addresses here of mechanics that again aren't necessary to display in the dashboard. So again, there's too much information coming back from the backend. If we go to community and I do a quick refresh here, so there's a recent messages API. So if I look at what this recent messages is getting back, you can see this is mine. So I posted this message. It has my vehicle ID, but it also has the vehicle IDs of everybody else who posted on this forum. So this is the main BOLA vulnerability in this application, is you have a forum and you're sending all of this data back to the front end, which really doesn't need to be there. So from an API design perspective, how can I validate what I'm doing is kind of weird. So one way to do that is you can compare the specification of the API with the actual traffic that's hitting the API. So if I go to my environment here, yeah, that's the right one. So what I can do here, so this is the no name view. I'm just going to use it to look at the APIs. So if we have the APIs here, we want the recent messages one, right? So we can see here the post recent. So that's that API that sends too much information. If I click on it, what you can see here is that we're saying here there's an API specification that's being uploaded. That's this YAML file here. There's a difference between the specification file, or what the developer tells us the API is capable of, and what we are seeing in reality. So these are the undocumented specification fields that are actually on the network. So this is actually being used by people refreshing that forum. So here I can see that there's a vehicle ID as part of the body response, which we didn't expect in the specification. So how do you make sure your API isn't vulnerable? This is potentially step one, is you look at the specification. It doesn't seem to match with the reality of the day. So you could go back and say, well, we have to either remove that possibility or we have to change our documentation, our specification file. So that's the first thing we can do. If I go back to the application itself, now I have a vehicle ID. So let's copy a vehicle ID of a person that's not me. So this one. So now the other problem is, how do I ask the API for that vehicle ID if I don't have like credentials of this Russell Rosenbaum person? So the idea would be I go to Postman. I paste in, oops. Here we go. All right, hold on a second. So what I can do is I can go back to my headers. I can see the API. I can look at the response. Then I can go back to Postman. And I paste in this other vehicle ID. And it's actually responding back with this Rosenbaum latitude and longitude. But I am using the same authorization token. So this is essentially a BOLA issue now, because I'm authenticated. So I'm logged in with my username and password. I'm getting authorization back in the form of this token. Of course, a bearer token is just nobody's checking the validity of that bearer token if it belongs to a certain person, right? So the whole idea of a bearer token is, if you have it, if you're bearing the token, that's where bearer comes from. The server is going to trust you that you can query this object. So essentially now I can read everybody's latitude and longitude. So what I'm going to trigger now, in the last couple of minutes of the demo here, so I'm doing this manually. So the idea would be, how can a security tool figure out what is going on at this particular point in time? Because again, we can't really match my user with that bearer token or with the object IDs that I'm trying to query. So what I'm going to do is I'm going to cheat a little bit. I'm going to run this collection here. It's very small on my screen. I apologize. So now what I did is I queried, so I read in all of the vehicle IDs from that forum using my little script here. And then I did a post to all of those vehicle IDs using the same bearer token. That's essentially what I did. So if I'm now going back to my security environment, and if I look at attackers and I refresh, I can see that this person, which is me, I'm based in Belgium, and I ran it through this Postman script. So I created this attempt to read all of that information. So essentially what I'm saying now is that we have a BOLA attack in the environment. on this particular API. So if I open it up, you can see it's on this location API that we are trying to break. And now the question is like, how did we detect that this is a problem? So the way that we detect that this was a problem is like this. So a normal user would access his own GUID and only once, right? And what I did now using that script is I accessed 10 different GUIDs using the same bearer token. So we're saying this is a problem. So why is it a problem? It's broken authorization, it's a Ebola attack. And what should you do about it? So essentially the guideline is implement some sort of role-based access control on the object level on the backend. So this is no longer a valid approach. What I can then do is I can say, I want to block this attack. So I have the ability here, because if you look back at our logical architecture, the way I'm talking to the backend is I'm passing the load balancer, but I'm also passing the web application firewall service, which is an inline tool. So the nice thing about API integration is it works both ways. So I can ask the AWS web application firewall. I'm going to do it for 5 minutes to block the attack, right? So I can do it here, or I can do it here. So if I say block attack for 5 minutes, I'm going to dynamically update the ACLs on the web application firewall. So now I'm blocked. So hopefully this works. So if I go back and I'm again querying using the same token, the same location API. Oh, it still works. Bad demo, bad demo. I know why this, yeah. It's cached here. All right, that's better. So now what we should see here is if we open this up, you can see that this attack has been blocked. So the idea is that you need some sort of correlation between the bearer token, which isn't really correlated to any user ID on that object that we're trying to query, with what that user is trying to do. So in this case, that correlation can only be made through learning over time what the behavior of that specific API is. So that's how we're sort of how we're trying to figure it out. So that's really the first attack in that crAPI toolkit. In the interest of time, I'll stop the demo there. But yeah, I hope you have some idea of how crAPI works and sort of what the sort of attacks, possible attacks are. But with that, I'll hand it over to Judy. There we go.
You want to take a few minutes of questions?
Yeah, I'm just trying to be conscious for food delivery, but we can take questions during the food delivery.
I'll position myself to your left as well, to be close to the speaker. Hi everyone, it's nice to meet you. My name's Yuri. It's my first time at an API meetup, so be gentle with me. I work for a company called Software AG. Software AG might ring a bell or it might not. We provide API management and integration technologies under the brand of Web Methods. I'm not here to do a sales pitch though today. When I was asked by Iris and Filip to come in today and deliver the presentation, they were very clear, make it a vendor neutral presentation. So I had to think a few minutes about, what am I going to talk about? And I figured I'll just talk about what I do day in, day out. So I do product strategy at Software AG for Web Methods. I live APIs and integration and B2B day in, day out. I've worked as consultant before. I've worked as a pre-sales consultant. I've worked as a product manager for a variety of different types of applications. Today, I get to do the fun part, and just the fun part. I don't have to take all the operational things with it, like being a product manager. You build the product, you have to deal with all the escalations, etc. Today, for me, it's product strategy, which means I get to do a lot of research. I get to talk to a lot of customers, analysts. I get to do a lot of reading, thinking, figuring out how things work and how they should work from a product point of view. So that's what I do on a daily basis. The subtitle is an opinionated view on the API ecosystem. Yes, it is a very opinionated view. I'm going to take you through that view. Essentially, what I've tried to do here is map out how I and a lot of my colleagues see the API ecosystem and how there's a lot of tools and techniques out there that help you improve both quality and security of APIs that you build. To me, quality and security go hand in hand. Actually, I consider security to be an aspect of quality. If it's not secure, it's not high quality. Who here builds APIs themselves, at least within the organization, and publishes APIs? See, one hand. Okay, that surprises me. I figured Chopin would, but it surprises me. Who consumes APIs? Okay, what's everybody else doing here? All right, so whether you build APIs or whether you consume APIs, there's a little bit in here for all of you. So you might be familiar with this phrase, shift left, shield right. It's something that's being used a lot in context of security lately. But to me, again, it also applies in terms of quality. And when we talk about APIs, for me, everything starts with specification. The specification is what details what an API is, what it does, more importantly, what it shouldn't do, because anything that isn't in the specification, it shouldn't do. So that, for me, is the center of the world when you talk about APIs. It's always the specification. It's not the code. Yes, you need the code that implements the API or the integration platform behind that does it. No, the API specification really is the center of the world because that is what tells everybody what it should do, what it shouldn't do, how to use it, etc. Does everybody agree with that or not? Okay, careful nods. Yes. Okay. Well, to me, the center of the world is Open API. You can disagree, but to me, the center of the world is Open API. Why do I like the Open API specification a lot? Because it has a very big ecosystem. One of the main things that I look at when choosing technologies is not just how well is that one technology suited to tackle my problem, but I also look at how well is it surrounded with complementary solutions that help me do whatever I need to do better. In this case, deliver better quality and security for APIs. I really like Open API, just like I really like Async API. Probably wouldn't surprise you because it's very similar to Open API. It's a specification for defining events essentially and how to subscribe to them. Does that mean I'm against things like GraphQL, OData? No, I'm not. I think every technique or every technology has its own place and deserves its own right. For example, I really like GraphQL for what they call experience APIs, serving mobile applications or serving portals for a specific purpose. GraphQL is great because it has a few techniques that help you optimize communication in queries and things like that. And when you talk about good quality, good standardization, and a good ecosystem of tools around it, Open API is by far my favorite. And it's my favorite because it has its uses both at design time and runtime. And depending on where you come from, if you have a lot of APIs to manage, you might be focused more on the runtime side. If you're building APIs yourself, you might be focused more on the design time. I'll start from the design time point of view and build up towards the runtime point of view. You mentioned you build APIs yourself. Sorry to put you on the spot. Code first or spec first? Spec first. I'm really happy to hear that. The difference between code first and spec first, right? Early days of APIs, people would be using something like Spring, for example. You write your code, you put some annotations in, it spits out the specification for you afterwards. The spec itself was an afterthought, which is okay because the spec matches what the code does and things like that, but it does mean that you haven't thought about the API as a product in itself. So for me, quality and security starts at design time. Contract first, design the specification so that you know what the API is supposed to do, and also explicitly leave out what it isn't supposed to do, and enforce styles. There's a couple of simple styles, like, make sure all of the owner fields are filled in and things like that. But you can go beyond that and make sure that you enforce styles for your specifications across all the APIs you build within the organization, so that all of the APIs that you build feel familiar. Once you know one, it becomes quick and easy to adopt the other ones. I'll throw out some names later, but I'll go through all the capabilities first. So contract first is my preferred way of working because it makes you think about the API specification, which I put at the center of the world. And enforcing styles is essentially, you have some tools that do linting, validation, statical analysis of a specification, parses the specification. It will tell you some things. It will tell you things about the style and the formatting of it, some best practices. Some of the tools out there give you security feedback on how the specification has been defined. So there's a lot of options there, which kind of brings me into this static analysis phase. You see the enforced styles coming back. There's a lot of tools out there that help you design specifications. If you don't do code first, at least validate your styles in your CI/CD pipeline. There's a tool like Spectral, for example, from Stoplight. Stoplight is a contract first design tool. They also have this linting tool that is being used for linting and validating specifications. You can plug it into the CI/CD pipeline. It's open source. You can extend it with your own rules. But by doing that, whether you design the APIs yourself, whether you take in APIs that are being developed by another team, whatever the situation is, when you take ownership of that API and that code and you basically integrate it into your Git repository, enforce styles. Maybe also do some static application security testing. So that's the same type of validation. Then obviously testing, we all know. Sorry, actually, before we go to testing, we do this for our code, right? We run linters on our Java code. We run linters on our Node.js code. We run linters on the specification as well. It's just as important. Then testing, obviously, there's a bunch of testing that anybody who has developed knows about. Unit testing. We all write unit testing for our code. We all do code coverage checking. Right? With every Git check-in, we don't allow the code coverage to go beyond a certain breakpoint. And then we disable the rules sometimes. But unit testing is very important. Obviously, integration testing is very important as well. Right? We're building APIs. Somebody provides a piece of code. Somebody else is going to call that piece of code. When we actually make the two parties work together, does it work as we intended? Or does it only work in the imaginary cases that we have in our unit tests? Important questions to answer. But there is an important situation which might complicate things. Imagine your Salesforce. That's not me, it's Kelly. Imagine your Salesforce. You build APIs. You put your APIs out there. You put your specifications out there. Anybody who wants to validate their code in using Salesforce APIs has only one option. Traditionally had only one option: integration testing. Right? You can build your own stubs potentially, but you would be building your own stubs, your own interpretation of how the Salesforce API works. If you call the Salesforce API, you're doing integration testing. You're talking to their actual test environment, to their backend system. That's where something like contract testing comes in place. Anybody ever heard about contract testing? It's a small company that was acquired about a year or two ago by SmartBear. people from SOAP UI and Ready API and other things. It's a company called PACT or PACT Flow, P-A-C-T. It'll be in the next slide. Essentially what they do is contract testing, which means you define a specification for the API and you define the test cases for that API specification. Not for your code, not for the client, you define the tests for the specification, both from a consumer and a provider point of view. It's the same set of tests. And that same set of tests can be used by the API provider to validate that it calls their code and they provide the right responses. And that same set of tests can be used by consumers as a stub. So the contract, based on the specification, becomes essentially a test of whether the integration will work without having to do integration testing. That is really valuable if you don't have full control over consumer and provider. If you have control over consumer and provider, do integration testing. If you don't, contract testing is really interesting. Which again, specification, right? Penetration testing. This is something that a lot of us skip, right? Something we're not used to doing when we develop code, when we write software. Penetration testing is not part of our daily work. Also because you can't expect every developer to be a penetration tester. So think about how you can automate this. There's solutions like dynamic application security testing. There's things like conformance scanning. What Filip just showed you in the Noname dashboard, I think is what triggered what rang a bell for me. He showed the specification and he showed the BOA attack and showed that the specification and the BOA attack don't really match. Or sorry, excessive data exposure. That was it. It was returning more data than what the specification was actually saying it was going to return. That is conformance scanning. Conformance scanning takes that specification, which we have carefully designed, runs tests against the application to see if it actually returns what it says it's going to return and not more or not less. Does the code do what the specifications say? No more, no less. So conformance scanning is an important part of penetration testing. Obviously, real attack penetration tests are also an option. And again, there's tools out there that will help you do that if you're not an expert yourself. Then on the runtime side, this is where I live in terms of what we sell as software AG. Lifecycle management for APIs. Versioning strategies for APIs, a version 1, a version 2. How are we going to deprecate the old API? How are we going to promote the new API? How are we going to promote adoption of the new API? Through development portals, etc. One of the typical, and actually one of the most occurring OWASP top 10 vulnerabilities is misconfiguration. Misconfiguration meaning, for example, not doing good versioning. Right? We're releasing version 2, we're deprecating version 1, 6 months later we're saying version 1 is no longer in use, and we forget to take it offline. Misconfiguration. Right? So things like versioning, promotion management, retirement, really, really important. And make sure that that has lifecycle management capabilities around it. It's not just doing that, it's making sure that you have the tools that support you in doing that properly. Policy enforcement, obviously, web application firewalls, or even better, API gateways. API gateways help you do authentication and authorization. They also help you do threat protection. Apply policies, things like rate limiting. The lack of rate limiting is, again, one of the OWASP top 10 vulnerabilities. So simple ways of actually protecting your endpoints, your APIs, on individual endpoints, by configuring policies for specific APIs, or by applying a blanket approach. I don't allow any more than 100 requests a second for any API, for example. Or doing things like injection protection, trying to catch SQL injection, something like that. So that's the world of the gateways. And then monitoring and analytics. Monitoring and analytics in various areas. We know monitoring obviously as performance monitoring. That's why most people monitor their software, is to figure out, is it actually responding? Is it giving us the SLAs that we want? but also monitoring in terms of adoption. Adoption feeds into lifecycle management, for example. It could also feed into your business model, right? If you sell the usage of your API, you want to know who's using it and bill for that, obviously, which is adoption and metering. But adoption in itself can give you a lot of valuable information about, for example, how many people are still using my V1. We've announced deprecation 6 months ago. How many people are still on V1? We've retired V1. We forgot to take it offline. How many people are still using V1? It's important to monitor. And obviously, I called it behaviors. I didn't want to call it security. But how do people use the API? It's broader than just security, but security is a really important aspect of this. How do people use the API? Do they use them for the purposes that you had designed to be used for? Or is it being used in other ways? For example, an API that is used to fill an account page in a web portal, is that being used to scrape user data? Those are different types of behaviors that you want to monitor and catch. Again, there's solutions that will help you do this, but it's important to be aware of this. Any questions about this? Anything you've seen that I've called out that you say, I don't agree? This is the easiest audience I've ever spoken to. So these are for me, anything I've missed? This is a challenge, I want to learn something. So this is for me what I think of when I talk about, quality and security. It doesn't just start with security for me, it starts with quality because security is an important part of that. If you have the opportunity to start on the left side, do so. Right? Greenfield scenario, you're building a new SaaS product, whatever you're doing, start on the left side and work your way through. You don't have to do everything at once. Think about what's important. Be aware that these types of solutions are out there and that you can use them when you encounter something. And work your way to the right. I'll come right to you. If you don't have greenfield and you've got hundreds or thousands of APIs to manage, consider starting on the left. Oh, sorry, on the right. So, yes, right. Consider starting on the right because it'll help you highlight stuff. Solutions that will tell you this is wrong, this is wrong, this is wrong. Then you go and prioritize. And by prioritizing, you can work your way back to the left to improve the quality and security from the very beginning. But depending on the scenario you're in, the situation you're in, we'll have to figure out on which end you start. So you had a question.
Yeah, you mentioned in penetration testing that it's lots of developers are not specialized in which I agree with. From my experience in some corporates, they have a specialized team that does penetration testing. How would that be a good idea to kind of outsource that to the external team that's more specialized? But then how do you fit that external outsourcing into the chain?
Yeah, so your question is, there's services out there, there's people that provide services to do penetration testing for you.
Correct.
What's the view on how you can integrate the services that they offer into something like this? Yeah. I think there's a lot of value in having people do this for you. I think there is, and this is again my personal opinion, but there is only so much that automated rules will catch. Right? Automated rules, automated penetration testing will help you catch a lot, but it doesn't help you catch everything. So these services can be really valuable, and there's different ways of doing this. There's people that will actually come in and help you do this as part of your development lifecycle, right? There's other ways you can crowdsource it. Somebody mentioned Inti de Keukelaar. You can use his platform and crowdsource penetration for yourself. It's a bug bounty platform. But it's absolutely a good idea. The question sometimes or often is, can you pay for it? Right? Because it becomes expensive to have a managed service for security. But it is absolutely a good thing to have. And if you can pay for it, you can allow it or can afford it, sorry, then I would say go ahead and do it. It also depends on the type of data you're working with and things like that, obviously. But if you're a bank or an insurance company, or make sure that you have some coverage there. Any other questions? All right. Sorry.
Yeah, something you were asking. What did you miss? What about you have an API version 1, and there is a, let's take Log4j.
Mm-hmm.
How you address that issue in your timeline?
So the question is, let me make sure I get it right. So you're asking me, how do you address in this timeline or in this view of the life cycle, how do you address known vulnerabilities popping up in known software libraries, and how do you make sure that you target that?
Mm-hmm.
So there's actually two ways of answering this. There's the easy one, which is static application security testing. A lot of these tools, I don't know if you know SNYK, SNYK.io, for example, or code coverage, Dependabot in GitHub. They're all solutions that kind of track your dependencies. They'll track your, they're analyzing your Maven POM file or your package.json, see what the dependencies are. They'll analyze the dependencies and the versions to figure out, are you using a vulnerable version of some library? That's one way. But it does kind of imply that you make this a continuous practice in your process. The other one is, and if you talk to people like Filip, for example, they will be able to acknowledge that there's still people out there that have APIs in production, live, open to the public, that are still vulnerable to that issue. I'm talking specifically about the Log4j vulnerability. So the other one is to monitor behaviors. Are people trying payloads that shouldn't be there? Are people doing things with APIs they weren't doing before, simply to try and abuse and exploit? Some of the gateways can catch it as well with injection attacks. It depends a little bit on what it is, shell scripting and things like that, or SQL injection, JavaScript injection can be caught as well. So there's not one answer to that question to me. But again, I'd say start early. Make sure that you track all the dependencies and that you scan those on a regular basis. Something like a CodeCov or a SNYK or Dependabot in GitHub will do that for you.
But that suppose that when you're developing and you're on the design phase, the vulnerability is published or known to use the SaaS. It's just code.
Sure. So yeah. So yes.
But what about that? You already finished the design phase. You're on production level. For example, what happened with Log4j?
Yeah.
Everything is done. You're in the monitoring and analytics phase. Last phase.
I'll give you the example of Dependabot on GitHub. It's one I use myself for my personal projects. It runs scans. You can configure it, run on an hourly basis, a daily basis, a weekly basis. And basically every Monday morning, I get a bunch of pull requests for stuff that needs to be upgraded and for whatever reasons.
Okay, and in such case, are you reiterating again? So you're restarting the specification and changing the specification to solve the issue?
But changing the specification might be necessary, but in the case of a Log4j issue, for example, we don't need to change any API specification. It's just something that's covered in the implementations. Okay. But it might be, and depending on the risk and the urgency, you would have to assess: do I tackle this today, or do I tackle it a little bit later?
But you will also always have the risk if you're updating or changing a library or package, breaking something.
Which is why we have things further down the pipe. Yeah, things like unit testing, integration testing, contract testing. I mean, we're dealing with software, right? It's supposed to work and always work the same way, but if you change something here, something breaks over there, it becomes difficult to manage. But that's why we have continuous integration pipelines to try and minimize that and catch that as early on as we can. Which is why I've called out automation via CI/CD a few times. Try to embed that into what you do. Before I wrap up, I just wanted to call out a couple of names. API design, solutions like Stoplight.io. Anybody using Stoplight or SwaggerUp? Great solutions for designing API specifications. Collaborative platforms, both of them integrate with your CI/CD pipeline, so you can make updates to the spec, commit it to your Git repository, push it to the developers to go and change things. Fully integrated into the lifecycle. Static analysis, I've already called out Spectral. Spectral is that linting tool that I called out for the API specifications, specifically OpenAPI. There's a couple of other ones, like our friends from Noname, who do security validation on the specification, make sure that you implement the best practices for your specifications. The other two I call out here, Akinetics and Nessus, are more code scanning. So they'll actually go and scan the code, static application security testing, make sure that you've got all your dependencies in order, similar like a SNCC or a Dependabot. Testing, obviously everybody knows Postman. Filip has used it for his demo. Everybody know Noname? Noname is the CLI tool, the command line tool from Postman. If you want to automate integration tests, if you find your use cases in Postman, they have a unique ID. You run Noname with the unique ID for your test collection, and it runs all those tests. And it gives you the feedback in your CI/CD pipeline. Really valuable solution to use if you're using Postman. Obviously, SmartBear has Ready API, which is their competitor for this, and PactFlow or Pact is the contract testing solution that I mentioned. Really valuable if you don't have control over consumer and provider. You only have control over one of the two. And obviously, mostly in the case where you're a provider for APIs, then you can provide your consumers the contract tests and they can code against that. Penetration testing, again, Noname, for example, but there's other vendors out there that do similar things. Some have different accents, some in different ways, but penetration testing automated. Or indeed, there's companies that do this as a service. So you can hire experts to help you with that. Lifecycle management, two very important components for me, the API gateway and the developer portal, or API portal, whatever you want to call it. I called it API gateway and developer portal because both are products under the WebMethods brand. Snuck that one in. Policy enforcement, obviously an API gateway. And then monitoring and analytics, again, the gateway should provide you with metrics. The developer portal should provide you with metrics and analytics. But there's other solutions out there that help you. For example, monitoring uptime. Anybody know alert sites? Chronitor? They'll ping your API on schedule, and they will report to you if it's not responding. Postman actually has that same feature built in. Security monitoring solutions, operational monitoring solutions, performance monitoring solutions. Once you start to Google one of these topics, you'll see all these names combined. I just figured I'd call a few out. All right. I've actually, sorry, one more question?
I have a question. Would it be wise to add things like CrowdSec or fail to ban somewhere on the right side?
Absolutely. As well? Yeah, it always makes sense to go broader than just APIs and API scope. Obviously, the focus of my presentation was on API security or API quality. I can't claim to be an application security expert. I don't want to claim that, but absolutely, it makes a lot of sense. I just focused on the API topics here.
But I mean, in the context of an API, then.
Yeah, absolutely. APIs are often, it obviously depends a bit on how everything's wired together, but traditional application architectures where there's an API layer to work with the existing application. Modern application architectures where you have microservices and APIs basically do everything, and the application is a layer on top that provides the user interface and the business process, etc. It kind of depends on the dynamics and the architecture of the application, but an API is a part of the application. So. Any more questions? All right, then I want to thank you. And if you do all of this, it's going to be blue skies forever. And with that, I'd like to wrap it up. Thank you very much.
Thank you.